Hello, welcome back. We just finished number 1 in investigation 6, and now we are, if I can find it, going to pick it up with problem 4. So we have, if you can imagine a bicycle at a bicycle shop, maybe it's upside down as they typically are, and we have the crank arm which spins, and of course the bike wheel spins a lot faster for a given input. And we're asked in part A of this question, number 4, to illustrate with a picture if we turn the pedal with, if the technician turns the pedal of the bike with his hands, it causes the bike wheel to rotate as he turns it, and for every one, if this is 1 radian of openness subtending this arc, then the wheel correspondingly will spin 4 radians, right? And I think this is and it doesn't matter where I indicate this crank arm. I could put the crank arm here, right? It's still going to correspond to a 4 radian change in the bike wheel. Okay, so now we are going to assume that our pedal is at the 3 o'clock position, and we have our wheel look like this, and that it has this valve that we use to put air in here. They're both at the 3 o'clock position. It says that the tire valve is 12.5 inches from the center of the wheel's rotation. Right, so that means the radius is 12.5. And it's saying let it theta equal the angle the pedal sweeps counterclockwise from the 3 o'clock position. Illustrate the location of the pedal and the tire valve on the circles we created in part A. So we know that if, say, the pedal is swept out 1 radian, then that is going to correspond to a 4, and do this in a different color, right? So this might be 1 radian, 1 radian, and that is going to correspond to a change of 1, 2, 3, 4 radian change. So now our valve will have gone from there to that position, whereas our pedal will have moved only 1 radian. I hope that's clear. Okay, so we want to write a function f that outputs the horizontal distance from the vertical diameter, so we know that's the cosine, in radius lengths. So by virtue of their saying or specifying that our unit is radius lengths, we know that's our standard cosine with respect to theta in radians model. So here they want an expression to define the angle of rotation of the tire valve. We know the tire valve is going to always for 1 radian change in theta, we are going to have a 4 theta change in the tire valve. And so here we want a function, use our expression from the previous, from part D, to write a function that call it g, where input quantity is theta, argument is theta, and we want it to relate the horizontal distance of the tire from the vertical diameter. That's our cosine model, and we know that for we know that that we're going to have a we're going to for a 1 theta radian spin of the pedal, there's going to be a 4 theta radian movement of the tire valve. Okay, so part F asks us for the theta for the pedal having a full rotation. Well, we know that that is our cosine of theta model. We know that one full rotation would be 2 pi in theta, right? That would be theta equals 2 pi. And now for the tire valve, since the tire valve is going to be spinning 4 times as quickly, we would say that the theta for the tire valve, if we wanted to know the period or the time it takes for one complete revolution, well, since it's occurring 4 times as fast, we would use theta for the tire valve is going to equal 2 pi, but we'd have to divide that by 4, right, because it's going to occur 4 times as fast, and that would tell us that pi over 2 radians, or pi over 2 radians would, it would take pi over 2 radians, or pi over 2 radians of spin of the pedal to correspond to the wheel making a complete revolution, or the tire valve, that is, on the wheel. Okay, and so part G of that question asks us to graph cosine G of theta equals cosine 4 theta, and we use G for cosine of 4 theta, and F of theta equals cosine theta on the same set of coordinate axes. So let's look at pi. That would be 1 revolution. This would be 1.5 revolutions, 2 revolutions. Maybe we'll go ahead and go up to 6 pi. Is this going to be enough room? No. Why don't we make this 2 pi, this 4 pi, 6 pi, 8 pi. We'll make this 10 pi. How about that? We'll go in 2 pi increments. So we know that our f of theta equals cosine theta. We're going to have a complete revolution after 2 pi, and then another complete revolution after 4 pi, 8 pi, or 6 pi rather, 8 pi and 10 pi, whereas at 8 pi it's going to take you know what, I just had this all messed up. I'm going to pick this up in the next video where I'll come in with some nicer pictures here to depict part G of this question. I'll see you then.